For this video, we're going to be looking at solving inequalities instead of equations. So the differences is we have a less than or a greater than sign. So this first one right here, this is a less than symbol. So to use a less than symbol, it does not include the or equal to underneath it. All right, it points to the left. So when we go to graph it, we're going to use an open circle, which looks like just an empty hole when we put it onto a number line. The reason we do that is that number is actually not included as part of our answer set. And that a less than is going to be graphed to the left. So if we were going to put that on an actual number line, we would use an open circle and we would shade this way. And I always kind of think of it, if I just made that symbol into an arrow, that shows me which way it needs to point. So less than is going to the left. The second one is greater than. We're also going to use an open circle, only this time we're going to point to the right. The third and the fourth one, we have a less than or equal to and a greater than or equal to. So that means the endpoint itself is actually part of our solution. So these are both going to be closed circles. So we fill them in, showing that that number is included. And again, the less than is going to go left. The greater than is going to go to the right. So things you want to remember as you're solving an inequality, you're going to solve it just like you do an equation. You do want to end up with your variable being on the left side of the inequality so that when you go to graph it, the arrows match up. And the only thing you have to remember extra on an inequality is if you multiply or divide by a negative number, then you're going to reverse your inequality symbol. So let's try a few of these. So if we think back to those same steps, we don't have any parentheses here, but we only have two terms on each side. So we're going to collect our variables, and we want our variables to go to the left. So we are going to subtract the 6x from both sides. And that leaves us 7x minus 6x makes just 1x, or just x. And then we have a minus 5. And on this side, we're just going to bring that inequality symbol down. And we end up with x being less than or equal to 4. All right, if we go to graph that on our number line, we're going to use the 3, the 4, and the 5. I always use 3 numbers. One smaller, one bigger, and then the number I need in the middle. Since it includes the or equal to symbol, we are going to use a filled-in circle on the 4. And it's pointing to the left that way. So from our endpoint, we are going to draw an arrow to the left. All right, for the second one, our variable is on the right-hand side. We want it to be on the left-hand side. So we're just going to actually take and we're going to turn this whole thing around. So we're going to move the negative 1/2 x to the left, the 12 to the right. And what that means is we also have to take the inequality and flip it around. It was opening toward the 12, so when we're done turning it from left to right, we have to reverse the inequality as well. All right, to solve to get rid of the negative 1/2 x, all right, we're going to divide by negative 1/2, which is the same thing as multiplying by negative 2 over 1. All right, so we're going to have x over here. We're going to have a negative 24 on the right, because 12 times negative 2 is negative 24. And our last rule was if we multiply or divide by a negative, we have to reverse our inequality symbol. So we're going to take it from a less than, and we're going to reverse it to a greater than. All right, our third one, similar to the first one, we are going to, we are going to subtract 5x from both sides to get our variable to the left. And that's going to leave us a negative 1x minus 3 less than or equal to 2. We're just going to bring our x, or our inequality symbol, straight down. Now we're going to add on our 3 to get our constants all to the same side. And we need to end up with a positive x instead of a negative x, which means we're going to have to divide by negative 1. So we have an x on the left, a negative 5 on the right, because 5 divided by negative 1 is negative 5. And when we reverse, we're going to flip our inequality symbol around because we divided by that negative 1 right there. If If we did divided by a positive 1 or a positive number, we wouldn't reverse it. So only if you actually divide by a negative number. All right, and for our last one, we are going to start, we have to get rid of these parentheses first, so we are going to distribute. So 3/4 times 4x makes 3x, and 3/4 times -1 makes -3/4. So we have a fraction in there, that's okay. All right, then on our other side, we have -6x minus 12. All right, so we're going to add 6x to both sides so that our variable ends up on the left. So that gives us a 9x minus 3/4 is greater than or equal to -12. Now we need to add on our 3/4. So we have 9x is greater than or equal to -11 and 1/4. All right, then we're going to divide by 9 to get our variable by itself. And if we do that, -11 and 1/4 is really -45/4. Divided by 9 is the same thing as times 1/9. And if we multiply those fractions together, we get -1 and 1/4. And we don't reverse it this time because we divided by a positive 9. So we would have x is greater than or equal to -1 and 1/4. You know what? We forgot to graph all of these. So if we were going to graph these, we would use -5, -6 goes to the left, -4 here. This time we're going to use a filled in circle because it includes the or equal to part. And we're shading to the right. The stuff that's greater than is always to the right. This one, we can do -1 and a -2, or -1 and 1/4 is in here, and we're going to shade to the right.